Okay, today's lesson is lesson 1-9, which is called direct variation. Now, so you should have your book open, first of all, to page 82. I am doing this video as well using Camtasia. So we're going to try that out again and see how this works for our last lesson. Direct variation essentially is says that a linear relationship is a direct variation when the ratio of y to x is a constant or k. Now, what that essentially means is that way back at the very beginning of the year when you were doing those graphing calculator labs, we were doing linear equations, and your linear equations were written in a y equals mx plus b format. You're going to see that a lot in algebra. You had y equals equations, and you had y equals something plus x or times x. So you had y equals 3x or y equals 3x, x plus 2. That, whatever that is, whatever that number is, or I erased it. I didn't mean to erase. Sorry. Y equals 3x or y equals 3x plus 2. Now, today we're not going to be talking about the plus 2 part, but whatever that number is that is with that x, that is called your k. Your k stands for your constant or your direct variation. Your k is your constant or your direct variation. Now, those are both very fancy words for what you learned about on the previous lesson, which is slope. Okay? Your constant of proportionality. That 3 means that that's your slope of your line. So in algebra, you have a y equals m, they call it mx plus b format that you use for an equation. It's y equals mx plus b. That's the format that's used most often when you are graphing or creating equations of a line. And essentially all this lesson is about today is understanding that there's a relationship between this variable y and this variable x, and that m, or today we're not calling it m, we're calling it k for constant, because we've been talking about constant of proportionality, we're talking about slope, we're talking about constant rate of change. All of those things mean the same thing, that it's a proportional relation. When it's a proportional relationship or when it's an equation of a line, it has that slope or that constant. So, and that's why we're using that k instead of an m. So k meaning constant or slope. So the direct variation, so all of those words really mean almost all the same thing. So if you could write in your notebook, constant, direct variation, constant of proportionality, what do we have before that? We had rate of change and slope. They really, and really unit rate as well. They really are all the same thing. They all mean exactly the same thing, okay? The difference really does come into play when we're talking about whether it's a proportional relationship or not, because a constant unit rate, rate of change, and those all have to be a proportional relationship. A constant, a direct variation, and a constant of proportionality and slope do not. All lines, whether they go through the origin or not, are going to have a slope. And if you have, and before, you know, when we're talking about unit rate, equivalent unit rates, and rate of change, those things all do have a proportion, are all for a proportional relationship. So you do have to have an understanding of that too, that there is a difference, you know, because some are for proportional relationships and some are for proportional relationships and not proportional relationships. Slope and direct variation and constant of proportionality, those words all are for things that are proportional and for things that are not proportional. They are for things that are a straight line, whether they're proportional or not. Okay? So, for example, in this picture here, you have a line that's going through the origin. That's a proportional relationship. That has a constant of proportionality. That has a direct variation. That has a slope. That also has a constant rate of change. Now, if I change this, or if I graphed a different line and I went like this, that line also has a constant of proportionality and also has a slope, but that's not a proportional relationship. So you have to have an understanding of that. Okay, that's important. All right. So today's lesson is all about understanding that you are going to have a relationship between y over x, and it's going to equal k. And a lot of times these equations, almost always these equations are going to look like this though. It's going to be y equals and then some number times x. And that number is k. Okay? That number is k, or your slope. Whatever number is with that x in front of that x is your slope, or is equivalent to your slope, your k, your constant rate of change, your proportional rate, your constant of proportionality. Okay, so on today's lesson, what you're going to be doing is you're going to be understanding or calculating what that slope is looking at different points on graphs and calculating it. Now again, your book is writing these slopes as decimals, and I am not a fan of that. They should write them as fractions. So in this situation, you have the height of the water in a pool is being filled. It's shown in the graph, and you have to determine the rate in inches per minute. So in this first point, it's 5 over 2, and then the second point, it's 10, or it's 5, 2, and then 10, 4, and then 15, 6, and then 28. Now, in slope, you're going to write it as y over x. So you have to write that as such. So it's 2 over 5, 4 over 10, 6 over 15, and 8 over 20. And then you simplify those down, and you really should have simplified those down, and you would have received an answer of, for all of them, if you would have simplified them down, you would have received an answer of 2 over 5. And you should have left it in simplest terms of 2 over 5. Your book instead went 0.4 over 1 and made it a decimal, and that really isn't necessary. You could have just left it as 2 over 5. That would have been fine. And then they said it's at a rate of 0.4 inches every minute. They wanted a unit rate. And you can make it a unit rate, you know, or, you know, if you wanted to, you could have made it a unit rate. In this instance, they wanted a unit rate. Okay, so in this first example then, in example A, it says 2 minutes after a driver enters the water, he has descended 52 feet. After 5 minutes, he has descended 130 feet. At what rate is the scuba diver descending? So, okay, you have 52 feet, and that is after he descends 52 feet, it says 2 minutes. I'm sorry, 2 minutes, so it's 52 feet. Oops. 2 minutes. And then you have 130 feet, and that is at a rate in 5 minutes. So then you have to just essentially simplify these. So 52 divided by 2 is 26 over 1. It's not going to let me write over that. 26 over 1. And then 130 over 5 is also then going to be 26 over 1. 26 feet over 1 minute. So your your answer then would be that it is, oh, I don't think it's 20, am I right? 25, oh yeah. So it would be then, he descends at 26 feet per 1 minute, or 26 feet every 1 minute. Okay, that would be your answer, at a rate of 26 feet every 1 minute. Okay, that's the first type of problem that you're going to be doing. If you could turn the page then to page 83. The second type of problem is you're going to be receiving an equation, and then you're going to have to then calculate or determine what the constant is. So the equation y equals 10x, example number 2, the equation y equals 10x represents the amount of money y Julio earns for x hours of work. Identify the constant of proportionality. Explain what it represents in this situation. Okay, so looking at that problem, we know that the constant of proportionality is 10. Okay. Now, what does that 10 represent? That 10 represents that Julio earns $10 every hour he works. Okay? So you have to take that slope, or that constant of proportionality, and you have to identify what that means in terms of the context of the problem. Okay? You have to be able to do that. So then look at B. B then says the distance y traveled in miles by the Cheng family in X hours is represented by the equation y equals 55. Identify the constant of proportionality and then explain what it represents. Well, the constant of proportionality is 55. Okay, because that is what is with the X. What does 55 represent? It says that y traveled in the distance y traveled in miles by the Cheng family in X hours is represented by the equation y equals 55x. So that would be then they traveled 55 miles per hour. So it would be 55 is, if X is the amount of hours, then 55 is the amount of I'm going to erase this. 55 then is the amount of miles, I keep messing that up, per hour the Cheng family, oops, now look what I did. Drives. Okay? All right. Turn the page then to page 84. Number 4 then says, determine whether the linear relationship is a direct variation, and if so, state the constant of proportionality. So now you have to figure out, is this linear or not? Is it a straight line? So to determine if it's a straight line, you could graph it. You could determine its unit rate. So 12 divided by 1 is 12. Oops, I need to turn on my markers. 12 divided by 1 is 12. 24 divided by 2 is 12. 36 divided by 3 is 12. 48 divided by 4 is 12. Well, that's a proportional relationship. Proportional relationships are linear relationships. So this then is, ratios are the same, therefore it's a linear relationship, therefore it's a constant of proportionality. So if it's a proportional relationship, therefore it has to be linear. So you can say then that it is a linear relationship. Now, what is its constant of proportionality? Its constant of proportionality is going to be its slope. Well, its slope, it has a unit rate of 12, so therefore its constant of proportionality, its k, is going to be 12, because it has a unit rate of 12 over 1. So 12 is its constant of proportionality, 12 over 1. Okay, and what would that be if you were to explain what that was? $12 every, and it doesn't say what the time is, so 1 hour, 1 minute, depending on what the time is, the element of time is. Okay, so your assignment then is to do number 1 and number 2. Complete number 1 and number 2 in the guided practice. Okay? And that's not going to be due until Monday, I believe, because tomorrow is Stats Day. So well, although I shouldn't probably say when it'll be due because this will be used again. So complete number 1 and 2 in the guided practice. Okay?